The gearbox is one of the unsung heroes in the vehicle driveline. Most drivers don't know why they need it. And some treat it with brutal contempt. The prime purpose of the gearbox is to ensure engine power is transmitted to the road wheels under all conditions, moving away from standstill, hill climbing and so on. The driver rightly expects to be able to do this with the minimum of effort. So the gearbox has to combine strength with sophistication. And that's what our design and development engineers are always striving to achieve. The r380 gearbox is the culmination of years of development. It combines simplicity of design with strength to provide the rugged reliability that our vehicles require. To build it, we've invested in the latest production equipment to ensure that the quality standards demanded by the development engineers are met. Of course, if a problem should occur in service, then we want these same quality standards to apply. And that's where you come in. It's up to you to diagnose the fault and put it right. For example, difficult gear engagement may be caused by a low oil level, a faulty clutch, or an incorrect linkage adjustment. Jumping out of gear may also be an incorrect linkage adjustment, or something as simple as an obstruction around the gear lever not allowing full engagement. And oil leaks are often caused by a blocked gearbox breather. The point we're making is that none of the faults we've just mentioned would require a gearbox overhaul, so it's important that you diagnose the problem correctly. However, if overhaul is necessary, then this training video will help you do that by showing you correct procedures for a complete strip, examination and rebuild. First, a word about good workshop practice. Our gearboxes are built to close tolerances, so a clean work area is important. And there are a number of essential special tools you'll need to avoid damage when removing or refitting certain components. So now let's run through the dismantling procedure. We'll assume you've already cleaned off the exterior of the gearbox and drained the oil. Don't forget to clean the drain plug magnet and refit the plug. Start dismantling by removing the gear change mechanism. Then remove the extension casing like this. Remove the selector shaft yoke and the speedometer driven gear. To remove the drive flange, tap back the lock washer tab, then hold the flange with tool LRT 51003 while removing the securing bolt. Pull off the flange and discard the O-ring. Remove this spool retainer and the extension casing bolts, noting the position of this one longer bolt. Then, making sure the center plate doesn't separate from the main casing, gently tap the extension casing with a soft-faced mallet to separate it from the center plate. Recover the speedometer drive gear and spacer. Temporarily fit a couple of slave bolts to secure the center plate to the main casing. Remove the oil filter. You can now see 5th main shaft gear, and fifth lay shaft gear, fifth to reverse synchro unit, reverse main shaft gear, reverse idler, and reverse lay shaft gear. Remove them like this. Start by using puller LRT 37009 and adapter LRT 37024 to pull off the lay shaft rear bearing track. The nut holding fifth lay shaft gear is tightened to a very high torque and then staked onto the shaft. So you need special tool LRT 37023 to hold the gear. Fit it like this. Then remove the nut and the tool and pull off the gear. Remove the interlock quadrant from the selector shaft. On the main shaft, remove this retaining ring and the split thrust washers under it. Drift out the roll pin. Then remove the main shaft bearing inner track using puller tool LRT 37009 with adapters LRT 37010. Now you can take off fifth gear bearing, it's a split bearing, the circlip, and fifth gear bulk ring. Make sure you keep each bulk ring with its gear. Remove the fifth to reverse synchro unit next, at the same time pulling off its selector fork and the interlock spool on the selector shaft. Then the reverse gear bulk ring, reverse gear, reverse gear bearing, reverse gear bush, and the selective spacer. It's fitted to control end float of the fifth to reverse synchro unit. We'll check it during the rebuild. Take off the lay shaft reverse gear and the oil splash shield. To remove the center plate, start by removing this plug and the spring and detent ball underneath it. Turn the selector shaft until this pin aligns with this slot. Then remove the slave bolts you fitted earlier and use a soft-faced mallet to separate the center plate from the main casing. Collect the other detent ball and spring. Now the main gear trains can be removed. Hold the lay shaft and main shaft while removing this spool retainer. Then, taking care not to drop the lay shaft, carefully ease out the selector shaft, main shaft and lay shaft as a complete unit. Remove fourth gear bulk ring and the input shaft. At the front of the gearbox, remove the clutch housing and the front cover. It will probably be tight, so you can ease it off using a suitable bolt threaded into the clutch release pivot post location. Remove the main shaft and lay shaft bearing tracks. We've now dismantled the gearbox into its major component assemblies, so they must all be washed off and inspected for wear and tear. But first, a word about sealing. You will have noticed that there are no gaskets in this gearbox. Hilo Grip 2000 sealant is used instead. This sealant will only work properly if the surfaces are clean and dry, so you must pay particular attention to all mating surfaces when cleaning if you want to avoid oil leaks later. So now we'll look at the major assemblies in turn, starting with the main case and centre plate. Incidentally, they're a matched pair, so they can only be renewed as a pair. Remove the main shaft and lay shaft bearing tracks from the centre plate, and the selective shims underneath them. These shims are for end float adjustment, and we will refer to these during the rebuild. Inspect all components for wear or damage, including the detent balls and springs. If necessary, press out the reverse idler gear shaft to release the thrust washer, idler gear and its bearing. When refitting, press the shaft fully home. Check the end float with a feeler gauge. It should be no more than 0.38 millimeters or 15 thousandths of an inch. Let's take a look at the extension casing next. Remove and discard the selector shaft and main shaft oil seals. Examine all the components for damage and wear, including the gate plate and the reverse inhibition cam. Don't forget to put locking agent on the threads of the bolt which secures the camshaft if you've taken it out. If you have to change the main shaft support bearing in the extension housing, drift it out forwards, together with the oil feed ring in front of it. To change the lay shaft bearing, you must first remove the oil pump. It's held in by these 3 Allen screws, not by the 3 Torex screws. With the Allen screws removed, it can be pushed out rearwards, and the lay shaft bearing can now be pressed out. Check that the oil pickup pipe and the drillings in the casing are not blocked. To refit the pump, first fit a new O-ring and smear it with petroleum jelly. It is important to fit the pump correctly or it won't work. It must be positioned in the casing with the word top at the top before pushing it into place. Make sure there's a good thread engagement before tightening the Allen screws. Then fit the new lay shaft bearing. Press in the new main shaft bearing and carefully fit the oil feed ring, making sure the tag on the ring locates correctly in the drain slot. When fitted, the indent in the ring should be visible and aligned with the drain slot. Inspect the gear change mechanism for wear or damage, and renew parts as necessary. Next, the main shaft. To remove the main shaft centre bearing, position the assembly in hand press LRT 99002 with suitable press bars behind first gear. Make sure the bars cannot damage the gear teeth before pressing off the bearing. Now you can press off the centre bearing cone, then remove first gear bush, first gear, first gear bearing, first gear bulk ring set, first to second synchro unit, second gear bulk ring set, second gear, and second gear bearing. The pilot bearing cone is removed in a similar way with the press bars under third gear. Press off the bearing cone, then remove the stepped spacer underneath it. third to fourth synchro unit, third gear bulk ring set, third gear, and finally third gear bearing. Incidentally, each bulk ring set is made up of 3 components. There are 3 of these sets, on first, second and third gears. They are identical, but they must be kept with their respective gears if they are going to be refitted. Similarly, each bearing should be kept with its gear. Inspect the main shaft for wear or signs of overheating, and ensure that all the oilways are clear. Check the gears and their bearings and bushes for damage or wear. Inspect the dog teeth carefully for signs of wear at the corners. Before dismantling the synchro units, check the hub to sleeve alignment markings. The first to second sleeve has 1 half moon, which aligns with the single slot in the hub. The third to fourth sleeve has 3 half moons, the center half moon aligning with the single slot. And the fifth to reverse sleeve has 5 half moons, center half moon again aligning with the single slot. To dismantle a synchro unit, carefully remove the 2 springs separate the sleeve from the hub and slide out the 3 slippers. Check that there is minimal rock between each sleeve and its hub, and between each hub and the main shaft. Inspect all the teeth for wear or damage. Pay particular attention to the teeth in the sleeve. Wear at these points, together with wear on the associated gear dog teeth, could cause a poor synchromesh action or jumping out of gear. To rebuild, it's essential to align the hub to its sleeve using the markings we've already described, and slide the slippers into place. When you fit the springs, ensure the center indent of the second spring is 1 slipper round from the first spring. Examine all the bulk rings for damage. Wear can be checked by measuring the gap between the bulk ring and the dog teeth on its gear, like this. The gap should be no more than 0.5 millimeters or 20,000ths of an inch. While we're talking about bulk rings, a word about identification. As we said earlier, the 3-part sets on first, second and third gears are identical. Fourth, fifth and reverse gears each use single bulk rings, but there are differences. Fourth and fifth gear bulk rings are identical and have a black-coloured molybdenum coating on the mating face, which is not grooved concentrically. The reverse gear bulk ring is grooved concentrically, but does not have a molybdenum coating. Now the main shaft rebuild. Make sure you lubricate all the parts as you fit them. Start the build by fitting the second gear needle bearing, second gear bulk ring set, and the first to second synchro unit. A marking on the synchro hub says second gear side, so fit the synchro unit with this marking towards second gear. Then fit first gear bulk ring set, first gear, its bearing, and bush. Make sure the bulk rings locate correctly in the hub before pressing on the main shaft bearing. To do this, you'll need the press again, and these 2 tools, Collett's LRT 37001 and adapter ring LRT 37002. Fit the collets in the press and locate the adapter ring on the collets like this. Fit the bearing on the main shaft and position it through the press so that the bearing locates squarely on the adapter ring. Press the bearing fully home, at the same time checking that the bulk rings remain located in the synchro hub. Before going further, check the end float of first and second gears, like this. It should not be more than 0.34 millimeters, or 13 thousandths of an inch. Now fit to the front of the main shaft, third gear bearing, third gear, third gear bulk ring set, third to fourth synchro unit with the longer hub boss facing third gear, and the stepped spacer with its larger diameter towards synchro unit. You'll need the special tools you used just now to press on the pilot bearing. Check that the third gear end float is within limits. If everything is okay, the main shaft assembly is ready to be refitted to the box. We'll look at the input shaft next. Inspect the shaft splines, gear teeth and bearings for wear or damage. If you need to renew the taper roller bearing, pull it off using the press with collets LRT 37001. Press on the new bearing using the same collets and the adapter ring LRT 37002. To renew the pilot bearing track, use slide hammer LRT 99004 with adapter LRT 37004 to extract the old track. The new track is fitted using the press with the collets and adapter ring to support the taper bearing, like this. Then use a suitable size of tube to press the track home. Now the lay shaft. As before, carefully examine the teeth and bearings. To change these bearings, you need the press again and collets LRT 37022 to pull the old ones off. To fit the new ones, fit the rear bearing first, using the same collets and the adapter rings supplied with them to press against the bearing inner track. Finally, don't forget to inspect the selector components. Wear on the bores or fork ends, or loose pins in the shaft, for example, can cause problems. Now that you've completed the inspection procedure and renewed any unserviceable parts, you can start to think about rebuilding. But first, you must work out what shims are needed to give the correct main shaft and lay shaft end floats. We'll start with the main shaft, like this. Select the thinnest shim you have available and measure its thickness. Fit it into the center plate with its bearing track. Then fit the main shaft assembly and the input shaft. Fit the main case. Secure it with slave bolts and tighten them to the correct torque. At the front of the box, fit the input shaft bearing cup and the front cover. Tighten these bolts to the correct torque too. Now stand the gearbox vertically like this. Turn the main shaft a few times to settle the bearings. Then position a dial gauge on the end of the shaft. Carefully lift the main shaft and note the reading on the gauge. Repeat it a few times until you're confident you have a consistent reading. The measurement you've just made is the actual end float of the shaft. The correct end float is 0.01 to 0.06 millimeters. That is 4 to 24 thousandths of an inch. So from the thickness of the shim you fitted, and from the reading you've just made, you can work out what thickness of shim is required to give the correct main shaft end float. If the measurement you've just made is, for example, 0.1 millimeters, and the end float you want to achieve is 0.01 millimeters, then you have an excessive end float of 0.09 millimeters. Or in other words, the shim you fitted is 0.09 millimeters too thin. If the thickness of that shim was 2.2 millimeters, then the actual shim thickness you need is 2.29 millimeters. The lay shaft end float is measured in exactly the same way. Dismantle the box, fit the thinnest lay shaft shim under the lay shaft bearing, fit the lay shaft, main case and front cover just as you did for the main shaft check. The end float you need is the same as the main shaft, so you can make the shim thickness calculation in exactly the same way. Now that you've made the calculations, take the box apart again and carefully select the shims you need to give the correct end floats. So we're ready to rebuild the gearbox. Remember, all the joint surfaces must be clean and dry before applying sealant, and lightly lubricate all the moving components before you fit them. Start by locating the main shaft and lay shaft end float shims that you've just selected in the center plate, and fit the bearing tracks. Fit the inner detent ball and spring in the center plate. You may find it useful to hold the ball in place with a suitably sized tube. Assemble the 1st to 2nd and 3rd to 4th selector forks and the front interlock spool onto the selector shaft. When correctly positioned, the pin on the shaft locates in the slots in the forks, and the ears of the interlock spool face upwards. Locate the selectors on the main shaft, slotting the forks over their respective synchro sleeves. Take care not to move the sleeves. Fitting the selector shaft and main shaft to the center plate requires particular care. Start by aligning the pin on the selector shaft with the slot in the center plate. When you fit the assembly, you have to be very careful not to disturb the 3rd to 4th synchro sleeve. If you do, it will probably dislodge its springs and slippers, and if that happens, you'll have to dismantle the main shaft to rebuild the synchro. So, fit the 4th gear bulk ring and firmly hold 3rd to 4th synchro unit like this, so that the sleeve cannot move on its hub. Carefully lower the assembly through the plate. When it enters, the end of the selector shaft will push out the tube you fitted earlier to temporarily retain the detent ball and spring. Check that the 3rd to 4th synchro has not been disturbed. Now fit the lay shaft. This can be a bit awkward too, so hold 3rd to 4th synchro as you did just now, and carefully lift the main shaft a small amount. Mesh the lay shaft with it, then lower the two together. Check again that the 3rd to 4th synchro has not been disturbed. Turn the selector shaft so that the pin and the interlock spool are both in the selector fork slots in the neutral position. Then fit the selector shaft outer detent ball and spring. Coat the securing plug with sealant before tightening it. Fit the input shaft. Then check that the dowels are correctly fitted in the center plate. Carefully apply Hylogrip 2000 sealant to the mating face of the center plate. Then fit the main case. Temporarily use some slave bolts to draw the casing onto the center plate. At the front of the gearbox, check that the snap rings are fitted to the lay shaft and input shaft bearing tracks. Then fit the tracks. Lubricate a new input shaft seal with the correct grade of oil, then fit the seal to the front cover with its lip facing the main casing. Apply sealant to the front cover mating face, Then fit the cover, making sure the shaft splines do not cut the seal. Also put sealant on the securing bolts before fitting and tightening them to the correct torque of 22 to 28 Newton meters or 16 to 21 pounds-feet. Check the dowels and fit the clutch housing. Tighten the bolts to 65 to 80 Newton meters or 48 to 59 pounds-feet. Align the front interlock spool centrally. Fit a new O-ring to the spool retainer and apply sealant to the securing bolts before fitting them. Now you can assemble the fifth and reverse gears at the back of the gearbox. Start by fitting the lay shaft reverse gear. Next, you have to check the end float of fifth to reverse synchro unit on the main shaft, like this. Fit the selective spacer, reverse gear bush, bearing, and reverse gear, fifth to reverse synchro unit and the circlip. Push the synchro hub away from the circlip and measure the clearance between the circlip and the synchro unit hub. Then remove the components you've just fitted. If the end float you just measured is incorrect, select a new spacer from the range available and recheck. Now you can continue assembling. Fit onto the main shaft the selective spacer you just checked. Reverse gear bush with its flange forwards, reverse gear bearing, reverse gear. Watch the next operation carefully. You have to fit the interlock spool, fifth to reverse selector fork, synchro unit and reverse gear bulk ring at the same time. So, remembering that the longer synchro hub boss has to face reverse gear, slot the fork into the synchro sleeve, position the spool, and carefully slide them over the main shaft and selector shaft. Make sure you don't cause the synchro sleeve to be moved too far and dislodge the springs. And don't forget to align and engage the bulk ring tags with slots in the synchro unit. Fit a new main shaft circlip, then the fifth gear bulk ring, fifth gear bearing, and fifth gear. Now you can fit the fifth lay shaft gear. If it's a bit tight, use the old securing nut to pull it into position. Never attempt to drift it on. You'll damage the front lay shaft bearing if you do. Fit a new securing nut. It has to be tightened to a very high torque, so you'll need to use special tool r380 again to hold the lay shaft while you tighten the nut to 204 to 231 Newton meters, 150 to 170 pounds-feet. Then secure the nut by staking it. Fit a new roll pin to the main shaft. Then fit the two split thrust washers and their retaining ring. It is important to fit the roll pin correctly. If it is not far enough into place, it will foul the oil feed ring in the extension casing. When fitted correctly, it must not stand proud of the split thrust washers. Now check the fifth gear end float with a feeler gauge. It shouldn't be more than 0.43 millimeters, that is 17 thousandths of an inch. If all is well, you can now fit the main shaft rear bearing in a track. Place it on the main shaft with its shoulder towards fifth gear. Don't drift it on. You'll damage the pilot bearing at the front. Instead, there is a special tool for the job. First, fit this adapter, r38021, into the end of the main shaft. Then locate tool LRT37015 over the shaft and thread its centre screw onto the adapter you just fitted. Now tighten this nut to pull the bearing track into place. For the same reason, you must not drift the lay shaft bearing inner track on. But if you warm it a little, it will drop into place easily. Don't forget the oil filter or the oil splash shield. Put some locking agent on the securing bolt threads before tightening them. Next, the interlock quadrant. When fitted, this pin should be to the right. You must put locking agent on these threads too. Now you can remove the slave bolts and washers you fitted earlier to hold the center plate in position. Then carefully apply Hylogrip 2000 to the center plate. To fit the extension casing, turn the oil pump rotor until its flats align with the flats on the end of the lay shaft. Align the oil filter with the oil feed pipe and carefully fit the casing. Tighten the securing bolts to 22 to 28 Newton meters, 16 to 21 pounds-feet. Fit the main shaft spacer, speedometer drive gear, and the drive flange oil seal, lip side inwards. Tap it squarely into place using a suitable sized tube. Don't forget the 4 prop shaft securing bolts when you fit the drive flange. Then fit a new O-ring, the flange washer, a new lock washer, and the securing bolt. Hold the flange with LRT 51003 and tighten the bolt to the correct torque. Bend the lock washer to secure the bolt. Fit the speedometer pinion using a new O-ring. Now centralize the selector shaft rear interlock spool, put some sealant on the spool retainer and fit it. The securing screw threads must be sealed too. Check that there are no burrs on the selector shaft. Then lubricate the lip of a new selector shaft seal before fitting it lip side inwards. And when you fit the selector shaft yoke, you must put some locking agent on the securing screw threads. Now you can fit the gear change assembly, making sure you position the spacers and mountings correctly. Then check the gear change operation for selection and correct bias. If adjustment is needed, do it like this. Select first gear, then use a feeler gauge to measure the clearance between the gear lever and the mounting plate. It should be at least 0.25 millimeters or 0.010 of an inch. If it's too small, slacken these 3 bolts and move the plate sideways to correct the clearance. Next, select third or fourth gear, apply a light load to the gear lever towards the right and check the gap between the bias spring and the cross pin. It should be 0.5 millimeters or 0.20 of an inch. If it isn't, adjust the height of this bolt until it's correct. Then repeat the check on the right-hand spring, with the gear lever lightly loaded to the left. Now turn both bolts down equally until the bias springs just touch the crosspin, and tighten the lock nuts. Move the gear lever back to neutral and check that it automatically positions itself in the 3rd to 4th position. All that remains is to refit the gearbox to the vehicle and fill it with the correct grade of oil. Don't forget to put some sealant on the level plug threads before you fit it. That completes the R380 gearbox overhaul. It's not difficult, but as you've seen, some special tools are necessary, and it's essential to carry out all the operations we've shown you if you're to do the work to our exacting standards and maintain our reputation for quality and reliability.